Hi everyone. So today we're going to be looking at problem S3 maze from the Canadian Computing Contest from 2008. So in this problem we have these mazes and we have to find what's the minimum amount of moves you have to do to get from the top left corner to the bottom right corner. And we're given multiple mazes per input, and we're given the columns and rows here of each maze. And at the end, we have to output the amount of moves. And if you can't solve the maze, you output -1. So the maze is made up of 4 different characters: a plus sign, a minus sign, a straight vertical line, or an asterisk. Now, the plus sign indicates from that spot we can move anywhere. The minus sign indicates that we can only move west and east of the minus sign. The straight vertical line indicates we can only go north or south, while the asterisk indicates that we cannot move to that spot. Okay, and let's go and solve this. So to solve this, I used a breadth first search approach, and let's get into it. So first thing I do is get t, which is an input, which is the number of mazes that we have to solve. And then I create my answers array, which will just be the array where we store our answers for each maze, and at the end we'll print it, and I make it of t size, and I'll start as -1, so that if there's no answer, it just stays -1. And count will store which iteration of maze we are on. So first thing I do, each time we go to a new maze, I increment count by 1. Then I get the row and column of the maze, and I create an empty maze array. Then here, I just create the actual maze, and it's a 2D array of characters. So now I create a first node object, and I created a custom class here called node, which has an x and y component, which these are just the x and y coordinates of the actual symbol. Count, which is how many moves it took to get to that specific spot. And symbol, which is the actual symbol, so like a plus or minus sign or whatever. And then I create an empty queue, which in this case I created it as an array, but really you should create it as an actual queue, but in this case, it doesn't really matter. And I append my first node into my queue. And now I create this visited nodes hash set, which will store which coordinates I've already visited. Okay, so this line of code just handles if the maze is just 1 character long. It will check that, and if it is, then it'll make the spot in that array in count equal to 1, which is currently the first node's count. Okay, so now I actually go through and search the maze for the solution. So my condition is while the queue is not empty, or while the length of queue is greater than 0, I get the first thing out of my queue, and I create current symbol to equal node that symbol. So this is just a variable that stores the current symbol that we're at in the maze. So now I have these 4 if statements that just determine if from that spot we can go up, down, left, right. So for going up, the first thing I do is check if the symbol can actually go up. Then I check if we go up, is there still space that we can go up with this line of code? Then, is the spot that we're going to, can we actually go there? Is it an asterisk where we can't go? And finally, have we visited this node already? So is it in our hash set? And if all of those conditions turn out true, then I create a new node, which is just the x and the y, the y when it moves up, the node.count plus 1. So since it took 1 move from the current node to get to that node, I just do count plus 1. And then the maze, node y minus 1 and node.x, this will just give us the actual symbol of the maze right there. Then I create this coordinates tuple, which is just the X and the Y components. And I add that to my visited hash set. And I also add this new node that we just created to the queue. And finally, this is just to check if that node that we just added, is it the node that we're looking for finally? So the bottom corner of the maze. And these are the coordinates for the bottom of the maze. If it is, then I just stop the loop. And in that count, I do the node.count plus 1. Because from that current node, again, you have to move 1 to get to the final space. Now I do the same thing for down. The only difference is, instead, if I go down 1, will I go outside of the maze? And that's the only difference. And again, I check now, is that spot an asterisk, and is that spot already visited? And then I do the same thing. For right and left, I just change the line going up and down into a minus sign. And I check here, will it go too far to the right that's outside of the maze? Is it an asterisk, and have I visited it before? If not, I do all the same thing again. Then for going left, is it too far to the left, and have I visited it before? Will I go beyond the maze if I go there? All the same thing. And then finally, at some point, it should change the answer to node.count plus 1. Or if it doesn't find a node, it'll stay -1. And then at the end, it'll just go through and print all of the answers. So I'll go and demonstrate that. And here I have a handy file that I have the sample input and sample output. So if we just put that there, and we see the outputs match. Okay, let's run this again. And let's try sample 2. And if we see the outputs match again. So that's my solution. I hope you found this useful. Stay tuned for more CCC videos, and this was Coding with Mike.